This lesson is using the Pythagorean theorem, so we're going to use this thing called the distance formula, which is very similar to the Pythagorean theorem, and I'll show you how come it relates to the Pythagorean theorem. But first of all, let's notice that there is 2 points that are given, and one is x1, y1, which is right here, and then the second point is x2, y2, which is given at this point right there. And so if you're plotting those 2 points, which is here and here, the line that we want to find is this right here. So this point right there. And that is going to be using the distance formula to figure it out. Now, if you look at the points also carefully, this x2 minus x1 is all of that length, which is over here. And then the y2, y1 is all of the length that is on the height right there. And so if you think about it, this is very similar to the Pythagorean theorem. But if I know the distance right here, and then I also know is the distance of the height right here, I can figure out using the Pythagorean theorem what is the hypotenuse, because basically the distance is the hypotenuse. If you notice the formula for distance, it is also the quantity inside squared, and so that's going to take the square root on both sides to figure it out. We'll do some more practice and hopefully that will clarify it. Let's look at example 1. Given 2 points, we can label this. It's very similar to the slope. I'm going to label this as my x1, y1, and then x2 and y2. Now, substituting each of those numbers into the formula, we have then as the quantity of the x2, which is -4, minus, and then the x1, which is 2, squared, plus, and then we have is the y2, which is -3, minus the y1, which is 5, squared. And all of this is under the square root right there. So let's go ahead and simplify. -4 minus 2 gives us -6, and we have a squared, plus, then we have is -3 minus 5 gives us -8 squared. And again, this is all under the square root sign. So now from here, let's go ahead and do the exponent. So -6 squared is like saying -6 times -6, which gives us a positive 36, plus, and then we have -8 squared, which is -8 times -8, and that gives us a positive 64, and this is all still under the square root sign right there. So from here, we're going to go ahead and add those together, giving us a square root of 100. And from there, we can always do our division ladder to figure out what is the square root of 100. So if I put 100 here, we want a prime number that goes into 100. Start off with a 5. 5 goes into 100 20 times, and is 20 a prime number? 20 is not a prime number, so we have to do another round of the division ladder. A prime number that goes into 20 would be 5. 5 goes into 20 4 times. Is 4 a prime number? 4 is not a prime number, so a prime number that goes into 4 would be 2. 2 goes into 4 2 times, and is 2 a prime number? It is. So now let's go ahead and put all of our prime numbers inside our radicand. So I have is a 5 times 5 times 2 times 2, and we can see that we have groups that come out of the radicand. So here's a group of 5 that comes out and a group of 2 that can come out. So now outside, the operation we would do is multiplication. So 5 times 2 is 10. So square root of 100 is equal to 10. So the distance of that 2 points is equal to 10. In example 2, we're going to go ahead and graph it out so you can visually see the points and also the distance formula as well. Taking our first point of -3, -2, we're going to go ahead and go to -3, -2, which is at this point right there. And then we have positive 7, 4. So 7, 4 would be a point that is over here. And so I'm going to go ahead and draw a line between those 2 points. Okay, so now from here, let's go ahead and create our right angle triangle. So I'm going to go across this direction, and from there I'm going to get the height. It's going to allow me to create our 90 degrees angle inside. And so from here, let's go ahead and try to find the height. In this case, if I go ahead and put 7, 4, the height of this is 4 and the height of this is -2. So the distance between 4 and -2 is 6. We're saying the distance from here to here is equal to 6. So now doing the same thing, if this is -3 and this is 7 over here, the distance between here to here would have to be 10. So if that's true, then we can use our Pythagorean theorem to find the green line, which is the hypotenuse. So using our Pythagorean theorem, which is then a squared plus b squared is equal to c squared, we know then let's call this a, and this is b. Then we have is 6 squared plus 10 squared is equal to c squared. Working out our exponent, 6 squared is 6 times 6, which is 36, and the number 10 squared will give us 100 equals c squared. And if we're looking for c, we want to take the square root on both sides, so square root there, and that's going to give us then 136 is equal to c times c. Let's work that out there, and we'll keep that onto the square root. So now the c squared, we can see that a group of c will come out from here, but we need to know is what is the 136. So let's go ahead and do the division ladder for 136. A prime number that goes into 136, we start off with 2. 2 goes into 136 68 times. Is 68 a prime number? It is not. So in another prime number that goes into 68 would be 2. 2 goes into 68 34 times. Is 34 a prime number? It is not. So a prime number that goes into 34 would be 2. 2 goes into 34 17 times. So now let's take all of our prime numbers and put it back inside our radicand. So we have 2 times 2 times 2 times 17. And we can see that only one group of 2 can come out. So in this case, 2 square root of, and the 2 times 17 remains inside the radicand. So 2 times 17, going back to this is going to give us 34 as equal to, and then c. So that is the distance that we have on the hypotenuse. In example 3, it is asking us to tell whether the triangle is a right triangle, and so we're going to use the Pythagorean theorem to determine if it is a right triangle. In our previous lesson, when we're given a triangle like this, we're looking for our 90 degrees. Our 90 degrees angle will be here. Opposite of the 90 degrees, this leg is C, and then from here I can call this base as B, and then this is A. Let's use our Pythagorean theorem. A squared plus B squared is equal to C squared. So our A is 9 squared plus our B is 40 squared, and our C is 41 squared. So we're going to go ahead and work it out to see if the left side is equal to the right side. So I'm going to leave a question mark right there. 9 squared will give us 81. 40 squared will give us 1600. And on the other one, 41 squared will give us 1681. So if we add the left side together, it gives us 1681 is equal to 1681. And this is a true statement. So then for sure this is a right triangle because the left side right here is equal to the right side. If both sides are not equal, that determines that it is not a right triangle.